Hello everyone! In this video, we'll once again travel back to the distant past of the solar system, but this time to a period 4.535 billion years ago, when the well-known rocky planets like Proto-Earth, Theia and others had already formed. You'll see what the entire solar system looked like at that time. All of this will be shown using the SpaceEngine planetarium as an example. And this system was created by the same author on Steam who made the solar system at the 4.55 billion years ago era. If you haven't seen those videos yet, I highly recommend watching them. And you'll find the link to the system from this video in the description. So, 4.535 billion years ago, the solar system was fully formed with fully developed rocky planets. There were 9 of them, including 4 that we would later come to know as Nabu, Aphrodite, Terra and Ares. In the coming millions of years, all of them would experience powerful collisions. The Sun had become a yellow dwarf and was in the early stage of the main sequence. The star's spectrum was already G6V. Its diameter was 1,307,916 kilometers. That's 6% less than it is today. Its mass was exactly 1 solar mass as indicated, planets. There were a total of 22 listed in the system, but that also includes dwarf planets. The temperature was 5,416 degrees Celsius. And here, as you can see, is the inner solar system. There are many planets here and a lot of their orbits intersect. Well, the first planet in the system is Vulcan. I'll be reading information from the description of this mod. So it says here about Vulcan that it's the planet closest to the Sun, the younger brother of the planet Nabu, but soon a terrible fate awaits it. So this is what the planet Vulcan looks like. It's a dwarf planet. Its diameter is listed as 4,231 kilometers and its mass is just over 2 lunar masses. The average temperature is 1,727 degrees Celsius. In automatic photo mode, the planet looks like this. I've landed on the surface and this is the view from here. Let's see what the sky looks like here. Here we can see a lot of neighboring planets. Here we have the planet Theia and here is the planet Apollo. In general, we'll take a look at all these planets one by one later. And of course, here's the view of the star itself. The distance to the Sun from here is 0.54 astronomical units. And next, guys, we have the second planet in the system called Nabu. Here is its orbit. It intersects with the orbit of Vulcan, I think, and also with the third planet, Apollo. There is an intersection of orbits. Here is the perihelion passage. Guys, this isn't just the planet Nabu, it's just one of its names, but actually it's Proto-Mercury. And here's some more information about this planet. It is the third largest rocky planet in the solar system, but in tens of millions of years, it will experience a giant collision. So Mercury used to have a mass that was almost 13% of Earth's mass, and Mercury's diameter was as much as 8,745 kilometers. And it has such an interesting terrain, you can see all these diverse areas. And here's a landscape like this, and it even seems like there's some kind of atmosphere. Let's check that, by the way. Yes, there is an atmosphere, but it's thin, only about 5% of one atmosphere. And this atmosphere consists of carbon dioxide, sulfur dioxide and hydrogen sulfide. The average temperature here is 1,730 degrees Celsius. And so this is how the star shines here, and you can see the neighboring planets. The distance to the Sun is 0.54 astronomical units. And I think it wouldn't hurt to watch the sunset on the ancient planet Mercury. It's interesting to see what it will look like. Enjoy watching! A crimson sunset, I really love them. And here is the third planet in the system called Apollo, and it says that it will collide with Mercury in the future. Let's see what kind of planet this is. This is a planet with a diameter of 5,162 kilometers and a mass that is 0.74 times the mass of the Moon. A scorching world with a temperature of 1,727 degrees, but since it only just formed, it hasn't really had time to cool down yet. And this planet will collide with Mercury, and Mercury will lose a lot of its mass. Also in this system, guys, there's an interesting planet, the fourth one, called Dyke. Let's fly over to it. And it's very interesting. This planet has another name as well, Phaeton. I think that many people already know what Phaeton is. It's a kind of, in fact, hypothetical planet that once existed in the asteroid belt. Although, who knows how it actually was? Share your opinion about this in the comments. Here it is the fourth planet in the system. The temperature is 1,727 degrees Celsius. Its mass is twice that of the Moon, and its diameter is 6,716 kilometers. I landed on its surface. And remember how the protoplanetary disk here used to be, so bright and vibrant. Here it seems like there's something as well, but also kind of not. I mostly choose stars, though sometimes I find asteroids. Yes, there are asteroids and planetesimals, but everything has cooled down, so it doesn't look as bright now. But we can see the neighboring planets very well from here. And they're in different colors too. It's as if they're burning, especially this planet right here. This planet, Apollo, is glowing with an orange hue. And here's the view of the star. The distance from this planet to the Sun is 0.77 astronomical units. Next, guys, some interesting planets are waiting for us. These are Aphrodite and Terra. For example, this is the orbit of Aphrodite, the future Venus. In this system, this person chose those names. And then there's also the planet Terra, which is basically Proto-Earth. So, what we have here are the largest rocky planets, almost like twins. But over time, one of them will become more important and prominent in the history of the solar system. Well, I think it's clear which planet that is. It's our home, Earth. So first, let's visit Aphrodite, that is Proto-Venus. Let's approach it. Here it is, Venus. Wow. Really beautiful, truly an Aphrodite. And overall, the average temperature is 1821 degrees Celsius, and the atmospheric pressure at the surface is already 90 atmospheres. Wow, even at this point in Venus's history, the atmosphere is already so dense. Well, let's see. The atmosphere is made up of water vapor, carbon dioxide, nitrogen, sulfur dioxide, and also carbon monoxide. The diameter is 11,122 kilometers, and the mass is 0.63 times the mass of Earth. That's a bit low in terms of mass at the moment. And the normal solar day is 16 hours and 48 minutes, not like it is right now. And the tilt is 46 degrees. I'm descending to the surface. This is what the surface of ancient Venus looks like. Because of the high temperatures on Venus, that's probably why the atmosphere was so dense. But over time, as Venus cools down more, the pressure will also decrease. So we can actually see the neighboring planets from its surface. Here we have the planet Nabu, and right next to it is the dwarf planet Vulcan. And can you see the star from here? The star is visible right there. So even though the atmosphere seems dense, the star still shines through. The distance from Venus to the star is shown as 0.75 astronomical units. Well, it's interesting. What would a sunset look like on ancient Venus? Enjoy watching. But here, it's got this slightly bluish or even more of a violet tint to it, which is quite noticeable. It's really fascinating, honestly. Let's take a look at Venus in auto mode, and I want to descend to the dark side of this planet. And here, there seem to be some cracks or something like that. You can see we have thicker cracks and smaller cracks, almost like rivers or something, but that's just an illusion. There are no rivers here. What we really have is a molten surface. What is this, anyway? I've landed. It's dark here, the sky is dark, everything is dark. It's like there are little canyons or something. Got it. Let's switch back to HDR photo mode. And that's pretty much how it looks here. And the next planet is quite special. This is our home planet, Earth, which has just recently formed. In other words, the ancient planet Earth, Proto-Earth. Let's fly closer and see what it looks like. And so, this is what our young protoplanet Earth looks like. Its characteristics: a diameter of 11,601 kilometers and a mass of 0.78 times that of Earth. Yes, its characteristics are a bit less than what we're used to. But guys, we all know that there will be a collision with Theia, and thanks to that, Earth will gain a bit more mass and size. And the Moon will be formed as a satellite. Its average temperature is 1980 degrees Celsius. At this moment, it has a somewhat rarefied atmosphere with elements of carbon dioxide and nitrogen. Currently, a solar day on Earth lasts 15 hours and 48 minutes, and Earth's axial tilt is 2 degrees. This is how Earth looks in auto mode. Of course, the view is stunning. The Earth hasn't completely cooled down yet. Let's take a look at the dark side of our planet. Oh, it looks like it's still burning here, even brighter. Well, of course, it's fascinating. So, shall we head to the surface? Let's take a look at the surface of the ancient planet Earth. Let's descend somewhere around here. And wow, the landscape is already quite interesting. Here I am on the surface, and there's the star. The distance is indicated as 0.82 astronomical units. So, does that mean that Earth used to orbit even closer to the Sun? I even opened the orbital parameters. I'm actually curious to see for myself. It says here the type is elliptical, but the eccentricity is small, only 0.017, about the same as it is now. So I want to fly around here a little bit. we can really see that Earth's atmosphere is thin. It's kind of yellowish, even above the horizon. And if we turn this way, what is that? Is that a volcano? No, it's a deceptive site. It's unclear if there are any volcanoes here. Let's fly a bit further ahead. So this is what the surface of our ancient planet Earth looks like. I wonder, what did sunsets look like on ancient Earth? Let's take a look. Enjoy watching. Wow, it's so red, really beautiful. And now guys, I think many of you are curious, where is the planet Theia? Actually, Theia's orbit is here, and Earth's orbit is here. As we know, they were almost on the same orbit, right? But at the moment, for some reason, the distance between them in this system is quite significant. Well, okay, that's just how the person who made this mod placed Theia. Maybe it was like that before, and later Earth moved. Still, at a distance of 1 astronomical unit from the Sun, and then they ended up on the same orbit. Here it even turns out that Theia is closer to Proto-Mars. Here's Proto-Mars, it's called Ares. You can see how many orbits are intersecting with each other, so there must have been some influences anyway, and most likely Earth was thrown off course. Well, anyway, right now we're interested in Theia, so let's approach it. Here guys is Theia, this is what it looks like. This is a hot airless carbonia as it's described. Diameter 9,296 kilometers. That's pretty big. Well, as far as we know, Theia's diameter was about the same as Mars. Mars has a diameter of over 6,000 kilometers. Here it's 9,296. So is that about 1.5 times bigger than Mars? Well, okay, fine. Its mass is listed as 0.33 of Earth's mass. And the average temperature is 1728 degrees Celsius. Descending to its surface somewhere around here. Here I landed in a flat, scorching area like this. There's also some kind of thin atmosphere here. The gases in its atmosphere give it this bluish tint. And here's the view of the star itself. Theia's distance from the Sun. Here it says 1.22 astronomical units. It seems there is some atmosphere, but it's not listed in the characteristics. Actually, nothing about the atmosphere. Here, I also turned on auto mode, and this is how Theia glows. It looks absolutely magnificent. Now let's move on. Our next stop is the ancient planet of Mars. Here, it's called Ares. Ares is a coal-colored planet and the smallest of all the rocky planets, if you don't count Artemis, which is located in the asteroid belt. By the way, there's still another planet ahead of us. Let's see. And here it says, life may soon arise on it. So life may arise on Mars. Well, yes, there are theories that there used to be life on Mars. In fact, this is that ancient Proto-Mars. This is what it looks like. Diameter, 6,779 kilometers. Mass, 0.10 of Earth's mass. Average temperature, 1,627 degrees Celsius. Solar day, 25 hours. Well, just like now, really. Let's also take a look at its dark side. Well, yeah, same here. The planet is in the process of cooling down. Everything as usual. Now let's try the automatic photo mode. Oh wow, this looks so cool. Look, I even took this shot for you. Just like that we see the red planet, just as we're so used to seeing Mars. Now switching HDR back on. Well, let's slowly descend somewhere into this fascinating region of Mars. Oh, this is already quite interesting, as we can clearly see. It also seems like there's a thin atmosphere, but again, the specs don't mention anything about an atmosphere. How is that possible? Seriously, I mean, isn't this some kind of thin atmosphere or what? What a wonderful view of the star. The distance to the Sun, 1.29 astronomical units. I suggest we take a look at a very ancient sunset on Mars to see how it might have looked back then. Enjoy watching. Nowadays, sunsets on Mars are bluish, but here it was incredibly red. And here the night sky opens up and we see the Vulcan planet, the planet Nabu, and also the planet Aphrodite, which is Proto-Venus, and then the planet Terra appears, which is Proto-Earth. Wow, that's cool. And so all these planets look fascinating from the surface of Mars. It's truly mesmerizing. And if we look further, of course, there's nothing else here. Yeah, and actually, these protoplanets don't have any moons. None at all. The next planet in the system is Artemis. It's located right in the vast asteroid belt. Well, let's fly closer and see what it's like. This is a dwarf planet. It's heated up to a temperature of 1,267 degrees Celsius. Its diameter is almost 2,000 kilometers and its mass is 0.24 that of the Moon. So, guys, it's just a dwarf planet. And here you have some information about the asteroid belt in this system. It says here that this primary asteroid belt is huge and massive, with millions of asteroids, including several parent bodies. The asteroids Ceres, Vesta, and Pallas shifted inward within the asteroid belt because of the Great Maneuver. Well, as we know, this was most likely due to Jupiter's Great Maneuver, which disrupted a lot of things there. And now basically these asteroids are cooling down. There's one notable asteroid here, Lutetia. It formed together with the inner planets and is located in the inner part of the solar system. Soon, one of the rocky planets will knock it off its orbit. Well, let's take a look at all of this. Well, here we can see that we already have Ceres. Although I didn't even hit it. Well, you see, no matter where I click, there are asteroids everywhere. So the belt here is really huge. No matter where I click, something is discovered. Well, let's start by looking at Ceres. Here, Ceres already looks quite familiar. And it has already cooled down to a temperature of 118 degrees Celsius. Let's also take a quick look at Vesta. So, Vesta is also very similar to how we are used to seeing it now. But the temperature is 263 degrees Celsius, which means Ceres has cooled down more than Vesta, and as we can see, Vesta's orbit here is located between the orbits of Ceres and the dwarf planet Artemis. And remember, I told you about the asteroid Lutetia? It's going to be knocked off its orbit. You can see where it is now. Its orbit is highlighted in red, so even Theia passes through its orbit, it seems. And it also crosses the orbit of ancient Mars. This is a large asteroid, almost 100 kilometers in diameter, more precisely 95 kilometers. Its average temperature is 161 degrees.